All right, so the situation we were dealing with here is a roller coaster traveling through a 35-meter loop. If the riders feel 2 times heavier than normal at the bottom of the loop, how fast is this roller coaster going? So we're dealing with this position here, and we have what force is acting? Which way is gravity acting? Down, and thus out of the circle. Okay, and what else is acting? Normal force, and it is acting into the circle and is larger than gravity. In fact, you're always going to feel heaviest at the bottom because you have not only gravity, but your inertia also pushing against the track and causing the track to push back towards the middle. All right, rule for vertical circles. Fc equals forces in minus forces out. Okay, we know what those forces are. Okay, we know that Fc will equal normal force acting in minus force of gravity acting out. Now, at this point, they want me to solve for V. How fast is it going? Okay, so that means I'm going to be solving for this, mv squared over r. I'm going to be solving for V. Okay, the problem is I don't know exactly, like a number, what Fn is. They just tell me that this person feels 2 times heavier than normal. Okay, how do you normally feel? Right, you usually feel 1 times the force of gravity. Right, so this is what you normally feel like, m times g. Your apparent weight is how you are feeling at that particular point. And it says 2 times normal. Well, what's 2 mg? 2 mg. Okay, well, what's 2 mg minus mg? mg. Yeah, 2 apples minus 1 apple is 1 apple. Okay, so what we end up with is this. mv squared over r actually equals m times v. And now I can solve for v. Right, so we're going to bring this back over, okay, and then m will cancel, and we'll be squaring. Look, it's the square root of Gur again. I mean, how many times does that happen? Okay, now, if this said they feel 3 times heavier, then this wouldn't be Gur, it would be 2 Gur. Yeah, exactly, because this would be 3 mg minus mg, and we would have 2, okay, left over. All right. So when we do that, okay, we're going to have that v will equal the square root of 9.81, and the radius of this circle was 35 meters. Okay, so we're looking at the speed has to be 18, actually it'll be 19 because we only have 2 significant figures, 19 meters per second. Right? So a question like that can be a little bit confusing because it doesn't seem like it gives us a lot of numbers to work with. But in the end, we actually didn't need a lot of numbers. Mass usually cancels, okay, and things like that. All right, I want you guys to copy that one down and give it a try. You're looking for the apparent weight. Which force is apparent weight? Fn, right. Okay, of a 75 kilogram person as they travel over the top of a 150 meter circle at 22 meters per second. If we're talking about a circle and it says it's a 150 meter circle, it means the radius is 150 meters. We never talk about diameter unless the question specifically says the diameter is this much, we mean the radius. Okay, because that's what we use in the formula. So it's a circle, it's a 150 meter radius. How are we doing on this one? Are we stuck? Do we need to go over it, or do we just need some more time? More time, okay. Okay, so first thing you always want to do with a vertical circular motion question is draw the free body diagram. We are talking about going over the top of a vertical circle. That means this force here is Fn, because it's the force of the track or hill pushing upwards, and then this force is gravity. All right, so we got our forces in and forces out identified, so that'll be Fg minus Fn. We're trying to find the apparent weight. Well, that's Fn. For me, I don't like solving for something if it's negative, so I'm going to add Fn over to this side, and then I'm going to subtract Fg. So I'm going to have Fc. So I'll have Fg minus Fc will equal Fn. All right, so Fn will equal m times g minus mv squared over r. Okay, so they told us the mass of the person was 75 kilograms, so 75 times 9.81 minus 75 times 22 squared divided by 150. All right, so 75 times 9.81 minus 75 times 22 squared. By 150. All right, so we're looking at an apparent weight of 494. Actually, we only have two significant digits here, so it'll be 4.9 times 10 to the 2 newtons. Okay, now here's something that's not in the question, but will come up on your West Edmonton Mall assignment that you'll be handing in. Okay? Oftentimes, a question like this one will have a follow-up that says, how many G's is this? Okay, so it's asking about G-force, or what's the G-force acting on this person. All right, so in order to calculate G-force, you might want to write this down somewhere. Okay, G-force is always the ratio of your apparent weight to your actual weight. So basically, you take Fn and you divide by Fg, and you'll have the G-force. Right? In this case, it's probably going to be less than 1. This person's going to feel heavier or lighter. Probably lighter than normal. That's usually what's produced in this situation. So we're going to have 4. We'll take that answer and we'll just divide it by 75 times 9.81. All right, so this person is feeling a G-force of 0.67 Gs. All right, so no, that's not. They feel about 2/3 as heavy as normal. Okay. At the bottom, yes. Okay, if you were to go over the top on anything, you're going to feel lighter. Okay. Everybody follow on that? Okay, so calculating G-force, and it doesn't happen very often, but just so you know, when it does come up, G-force is the ratio of your apparent weight to your actual weight. Okay, so this is about the Vomit Comet, that plane that they used to train their astronauts with. Okay, that we watched the Russian version of there in that OK Go video. I want you to answer this question about the Vomit Comet. Okay, the radius of the circle is what we're looking for here. How big of a circle does NASA's Vomit Comet have to fly in to give its riders a feeling of apparent weightlessness if it can fly at 210 meters per second? Okay, the key word, apparent weightlessness. Okay. Okay, so the key to this one is they have a feeling of apparent weightlessness. We go over the top of a vertical circle to produce that feeling. Okay, and when you're apparently weightless, you are not actually weightless. Gravity is still pulling on you, but something is zero. What is it? Fn, because that's apparent weight. And if you're apparently weightless, Fn is zero. All right, so we don't have any normal force, which means there's only one force. You're a projectile. It's gravity. Okay? So that means then that Fc equals forces in, gravity, minus forces out. Nothing. So we're left with Fc equals Fg. And that'll be mv squared over r equals m times g. And we're looking for the radius of the circle this time. So we just manipulate for r. So we bring it over here. Mass will cancel. Okay, g will end up underneath. And we'll have 210 squared divided by 9.81. That'll give us our radius. So is it going to be a pretty big circle?
Yeah.
Yeah, and it has to be. I mean, this is a big plane. It can't make sharp turns. All right, so it's a 4.5 kilometer radius circle. Okay? And that's not that unrealistic. Remember, these people said they were feeling weightless for like almost 30 seconds at a time. That's a big circle. All right, so 4.5 times 10 to the 3 meters would be the radius of the circle that plane is going. All right, these are all examples of the types of questions that I would put on a quiz or a unit exam about vertical circular motion. Okay. All right. Now, I've got a worksheet on circular motion I want you guys working on today, because I think on Monday we're going to do the assignment on circular motion, as well as do all the measurements we need to do for what's next involved. Okay, we're going to measure our steps and things like that that we're going to need for measuring things when we're actually at the park. So we'll do all that on Monday, and you'll get your data booklets on Monday. Got to make sure you don't lose those between Monday and Tuesday, okay? Because if you do, well, you won't have anything to write all your data in. It'll be very difficult to complete the assignments. Okay? Also, a reminder to those people who are not going on the trip with us that you still need to come to class as per regular on that day. I do have a sub book, so they will be in here to supervise you and give you the alternate assignment for what's involved. Okay. All right. So the worksheet is on Google Classroom as always. Okay, and we're looking at just the vertical circular motion questions. Okay, so they start at the bottom of page 2 and continue on to page 3. Right, so that's what I want you guys working on right now. Okay, they start out pretty simple, but they're going to get more complex as we go along. Okay, that's what we're working on. Remember, on Monday you're getting an assignment to do with all types of circular motion that we have covered thus far. That's the halfway point of the unit. Okay, so we got to be ready to move on here. All right, so looking at number 3, okay, the student has a weight of 655 newtons. So Fg is 655 newtons. While riding a roller coaster, the student has an apparent weight of 1,950 newtons. Okay, at the bottom of a dip that has a radius of 18 meters. Okay, what is the speed of the roller coaster? So we're dealing with this spot here, okay, where Fn is acting in and Fg is acting out. Okay, we're looking for the speed of the roller coaster. What do we not have that we need? Mass. They gave me the weight. The mass. Can I get the mass from the weight? Yeah, I got to divide 655 by 9.81, but I can do that. Okay, so we got 66.76 kilograms. All right, now I can put in my FC equals forces in. That'll be 1,950 minus 655. Okay, Fn minus Fg, forces in minus forces out. All right, I want to solve for the speed, so I'm going to multiply both sides by the radius, and then divide by the mass. And then square root. That'll give me the speed of the roller coaster. So V will equal the square root of 1,950 minus 655 times 18 meters divided by 66.76 kilograms. All right, so we're looking at a radius, or sorry, a speed of 18.7 meters per second. Mine says 18.8? I maybe rounded off the math because I was in a hurry. That's probably it, right? Yeah. So, if yeah, my key says 18.8. It should be 18.7. Okay. All right, any other ones giving us trouble? Okay, keep going then.